What if I told you that billions of black holes are passing through the Earth right now? That a telescope worth billions of dollars has called into question the main theory of the origin of the universe? And that systems have already been found in our galaxy where several planets could be suitable for life? It sounds like science fiction, but these are real data from modern science. In this video, we'll figure out what would happen if a black hole appeared near Earth. Why James Webb's discoveries shocked astrophysicists. And how close have we come to answering the main question, are we alone in the universe?
One day, the famous astrophysicist Neil deGrasse Tyson cheerfully said that if a black hole visits us, the solar system will have a bad day. After all, there's nothing worse than being broken down into atoms. But we're used to thinking that black holes are somewhere far away in other parts of the universe. But what if one of them literally appears at our doorstep? What would happen if an uninvited guest, just 1 millimeter in size, settled near our Earth? Physicists asked a similar question in 2008 when the Large Hadron Collider was launched. Back then, many scientists, including Stephen Hawking, feared that this greatest invention of mankind could create numerous microscopic black holes that would consume everything around them, and we would cease to exist forever. Moreover, these were far from the only problems that were predicted by the collider's opponents. However, more than 10 years have passed since then. If you're watching this video, it means that the Large Hadron Collider is operating quietly on its own and isn't creating any dangers capable of destroying the Earth. Or is it just for now? In fact, to create a mini black hole, you would need 10 to the 15 times more energy than the Large Hadron Collider can handle. But beyond that, even if we managed to use such an enormous amount of energy to create a micro black hole, we would need to work with the fourth dimension in space, which in this context is not particularly well studied or understood. But let's suppose that we somehow miraculously managed to create a microscopic black hole in our limited and pitiful 3D world. I hate to disappoint those who are eagerly awaiting the apocalypse. That will have to be postponed for a while, because in this case, the mini black hole will most likely evaporate instantly due to the so-called Hawking radiation. After all, black holes not only absorb energy, but also emit it. Therefore, the Large Hadron Collider does not pose any threat to us at all. At least in any case, until we learn to use a large amount of energy and completely evaporate. We are exploring the fourth dimension in space. Nevertheless, microscopic black holes can appear even without the Large Hadron Collider. The fact is, right now billions of black holes are passing through our planet. So what's happening? Are we doomed? And will Earth soon be torn into tiny pieces by mysterious cosmic objects? Relax, it's not that bad, at least for now. After all, our multi-million army of black holes has been attacking our home planet for billions of years. At the same time, the individual mass of a black hole can reach up to 100 tons, but their size does not exceed that of an atom. Such a small diameter, accordingly, creates a small event horizon, a hypothetical line beyond which space bends and time, and matter begins to be absorbed and torn apart atom by atom. For this reason, a mini black hole can't even absorb the bacteria on our dining table. But even if it starts feeding on our home planet, it will take a very long time. In fact, several billion years. By that time, humanity will probably have gone extinct. Otherwise, it could have found another place to live in the universe. However, there is one thing. If the diameter of a mini black hole increases to a size visible to the naked eye, the events will be completely different. We won't confuse your minds with complicated calculations from the strange world of advanced physics. But, according to calculations, a black hole with a diameter of 1 millimeter would have a mass of more than 5 lunar masses, which is about 11% of the mass of the Earth. The scale of a black hole's influence depends on where it is located, on the surface of the Earth at the center of the planet, or, for example, in the room of a guy you hate. Let's suppose that a black monster, 1 millimeter in size, is located on the surface of the Earth. The sphere of influence of the black hole is about a third of the Earth's radius, about 1,320 miles, which would lead to a noticeable increase in the Earth's overall gravity, and this, in turn, would affect the Moon's orbit. It will deviate from its current path and begin to move in an elliptical orbit. But if the Moon only changes its course and survives, we and all matter in the immediate vicinity of this monster face another, even more terrible fate. If we were nearby, we would be torn apart. And it would happen so quickly that we wouldn't even have time to blink. If it settled with us, the black hole would deliberately move to the center of the Earth, and nothing and no one would be able to stop it. Without any usual obstacles, it could swallow everything and reach the center of the Earth in just 42 minutes. The insatiable monster passing through the core would reach the other side of the surface in about the same amount of time. But the black hole won't stop either. If its relative speed is at least 12 kilometers per second, it will orbit the Earth along with its sphere of gravitational influence. With each orbit, the Earth loses its mass. Thus, the black hole began its consumption, absorbing the crust and most of the mantle. This means our complete destruction and the destruction of all life on the surface of the Earth. But before swallowing all living things, the black hole smooths out the edges, apparently to make it easier to consume. Thus, the gas will twist into a gravitational spiral, much like sugar does when making cotton candy. And our planet would simply turn into a broken disk of hot rock. The material of the formed disk will produce a lot of heat. It is assumed that it will have a temperature of about 6,000 Kelvin, comparable to Earth's core or the Sun's surface, because the disk will radiate as if it is highlighting the black hole. It would be an amazing and at the same time eerie sight, because the black hole, like a vampire, would have sucked the glow of its energy from the planet. Scientists believe that the cosmic monster would need 5 billion years to finally consume our planet. During this period, Earth's mass will increase a lot, but the shape of the planet we know will change beyond recognition. It would probably be similar to the fall of the legendary Pompeii, which was destroyed by burning lava, only on a cosmic scale. In just a few hours, the beautiful and densely populated blue planet will turn into an uninhabitable patch of space, ruled only by crumbling crust, lava, and hot gases. Naturally, the disappearance of Earth would not go unnoticed. The asteroid belt would be disrupted, leading to frequent collisions throughout the solar system for 1 million years. To complete the chaos, there would be no place for life, which would simply become impossible. For now, these are just terrible assumptions and theories, but they are still far from us. In any case, in another 5 billion years, humanity might start building Noah's Ark and move to some other planet. And maybe in another galaxy, because it's far from certain that the solar system can last that long. But right now, you can safely let billions of mini black holes pass through you without fearing that your atoms will be broken apart. although it would look impressive. Do you like stepping out of your comfort zone? Did you know that you can step out of it, not only by changing your job or where you live? The fact is that after the James Webb Telescope entered the cosmic stage, orthodox astrophysics has come closer than ever to a grand failure. This latest optical instrument has an amazing superpower. It can peer so deeply into the universe that no telescope ever built before has reached such distances. So what did James Webb see at a distance of almost 14 billion light years? That is, at the very origins of the macrocosm. Its first discoveries have already shown that the familiar information about the possible origins of our world is just a colossus with feet of clay, which is about to collapse. But that's not a bad thing. Who knows? Maybe a new, more plausible theory will emerge from its ruins. So in schools and universities, we are always introduced to the generally accepted theories that supposedly explain the origin of humanity or the universe as a whole. This is not surprising, since this question will never lose its relevance. Just remember the ingenious theory of Charles Darwin. It is said that at the end of his life, he, like Gogol, intended to destroy all his works. And first of all, his grand work, The Origin of Species, considering it absurd. Although some consider this story to be an urban legend. Be that as it may, the catastrophic lack of evidence has not stopped ministries of all kinds from still including Darwinism in school and university curricula. Right now, something similar is happening with the Big Bang Theory. It's simply falling apart at the seams, and the reason for that is the James Webb Telescope. What is this now legendary telescope? James Webb is not just some Galilean telescope, but a massive orbital infrared observatory. Its mirror alone is 6.5 meters in diameter. This colossal device was created to search for exoplanets and protoplanetary disks, to study water worlds, the solar system and its small bodies in more detail, and also to look as far back into the past as possible to finally understand the origin of all existence. And James Webb is doing an excellent job. Since the summer of 2022, it sends quite clear photographs of potentially habitable planets that have water and carbon dioxide in their atmospheres, images of gas giants and nebulae in whose embrace protostars are forming. But the most important discovery made by this amazing telescope concerns galaxies, and it has already laid the foundation for a future cosmological revolution. What do we actually know about galaxies? They come in the form of ellipses, spirals. Some of them look like lenses or have a bar. Some galaxies are much smaller compared to others, and they are called dwarf galaxies. There is also a type of object that does not fall under any of the classifications. In short, it's a very diverse family. We live in one of these galaxies called the Milky Way. Galaxies play a significant role in the Big Bang Theory. It is believed that they appeared no earlier than 5 billion years after the mysterious detonation of the singularity point. But James Webb made scientists doubt this. What is the Big Bang Theory if we put it in simple terms? About a century ago, astronomers discovered that stars seemed to be moving away from us in different directions. What did they conclude from that? Something must have given a significant push to this process. Gradually, scientists, through indirect calculations, came to the idea that about 14 billion years ago, from an infinitely small and hot singularity, something monstrous was born. As a result, matter began to expand uncontrollably, and the first stars appeared, mostly consisting of hydrogen and helium. After thousands of years, they gradually exploded, filling space with heavy metals produced through nucleosynthesis, from which in turn, new generations of stars were formed. Then, the stars merged into galaxies, and all of this was accompanied by the constant expansion of space. Later, this long process was called the Big Bang Theory. But is it true? Everything in the universe evolves. We mentioned stellar evolution above, but galaxies also have their own regular stages of development. If we believe the Big Bang theorists, galaxies simply couldn't form during the first billions of years after our universe appeared, not to mention conglomerates made up of several formations. In addition, the stars in early galaxies could contain nothing but hydrogen, helium, lithium, and possibly beryllium. According to scientists' estimates, these elements appeared during the Big Bang, literally out of nothing. But James Webb completely shattered these theories. It managed to reach the origins of the formation of the universe and see something completely different there than what was expected. At a distance of more than 13 billion light years, scientists saw quite mature galaxies with high metallicity and a huge number of stars. That simply couldn't be. But you can't argue with photographic evidence. What does this mean? In short, either the universe is much older and the process of forming metal-rich stars and their clusters happened much earlier, or the Big Bang theory simply doesn't hold up to scrutiny, and all this time we believed in an illusion. So, we'll have to look even further to check if these statements are true, and still find the pioneer galaxies, spherical or elliptical. In essence, James Webb is currently successfully combining the functions of a telescope and a time machine, which science fiction writers have dreamed about for so long. Its gaze goes deeper and deeper into the depths of the universe in search of cosmological truth, finding objects that have long ceased to exist. But what is it destined to find in this darkness, older than the oldest things? It is obvious that space holds many mysteries that do not fit most of our ideas. Few people know what astronauts keep silent about. Those who have been, for example, on the International Space Station, or those who have landed on the moon. Perhaps they saw something after which it was considered reasonable to shut down the lunar mission for an indefinite period. And right now we're not talking about the Solaris effect with its vivid hallucinations, where supposedly the universe itself communicates with a person, but about other, more real events. Let's not voice unverified theories. Let's just mention that some astronauts, after many years, still reveal bits of classified information. For example, in 1977, George Leonard wrote a book in which he included NASA photos showing strange objects located on the surface of the moon. The author claimed that the photos were genuine and were deliberately being hidden from the public by the American government. What were these objects? Ruins of some ancient structures, possibly built by a long-lost civilization. It was only in 1996 that NASA representatives held a press conference on this topic, where they had to give a lengthy explanation in order to avoid a scandal. However, let's get back to the ancient galaxies and the strange discoveries of James Webb. Cosmologists are simply shocked by what the telescope has sent back. According to orthodox theory, it's simply impossible for the first galaxies to be filled with such a huge number of stars, and even more so to contain the entire periodic table. It's about the same as what happened with the fossil record that was supposed to prove Darwin's theory. During excavations, archaeologists invariably found the bones of already fully formed animals and birds. But where are the missing links and transitional forms? Those that don't resemble any particular creature and clearly demonstrate the process of evolution. There are very few of them, but scientists aren't concerned. If we extrapolate this situation to the field of cosmology, we see the same thing with galaxies. No one has canceled the stages of stellar and galactic evolution. That's why astronomers are now in complete confusion. Many of them are unsure and wonder, did they do anything right at all? Or is everything that was considered true just a fiction? It would seem that it's time to convene a global conference and overthrow the Big Bang model as a theory that has not withstood criticism. But no one is going to do that. Why? The Big Bang theory is the foundation, and if you destroy it, the huge structure built over the years on familiar ideas will collapse. That's why scientists worldwide chose a new approach. They plan to reconsider the algorithms of star formation and the evolutionary processes that give rise to galaxies. In other words, it's easier for them to give up a part than to give up the whole. Of course, after such obvious evidence provided by James Webb, the creationists became more active, immediately replacing the evolutionists and pushing them off the stage. The representatives of this religious philosophical doctrine are firmly convinced that the universe and everything in it appeared through an act of creation. Simply put, it was created by some kind of superintelligent being, known by various names. But what are the pillars that support the idea of the Big Bang? First of all, the singularity is always mentioned, which even quantum physicists have a rather vague idea about. How, for heaven's sake, can one imagine, let alone describe, an object of infinite density and temperature? On the one hand, everything seems logical. An explosion should have an epicenter. However, pay attention to a particular feature. If you observe galaxies from the Earth's surface or from our planet's orbit, you will see that these objects are moving away from Earth in all directions. So does that mean our planet is the center of the universe? The place where that very singularity was located? But that's absurd. If you, as an observer, arrived on any other planet, you would see the same picture. Galaxies would similarly be moving away from you in different directions. What does this mean in practice? Most likely, if the Big Bang did exist, then it didn't happen at any specific point. Space itself expanded, literally every single pixel of it. For example, astrophysics professor R. Ratcliffe from the University of Oslo believes that the region where the expansion began is called a point only figuratively, for better understanding. Therefore, you shouldn't take this literally. What other prerequisites are necessary for the Big Bang theory to exist in a viable state? It's a mere trifle. Just two hypothetical things: dark energy and a particle called the inflaton. Both components are also in the realm of theory and semi-scientific fantasies. According to the proponents of the Big Bang theory, it was the inflaton that took responsibility for the lightning-fast expansion of the universe, just microseconds after the pivotal event. Some astrophysicists believe that the inflaton is nothing other than the legendary Higgs boson, or, as it is popularly known, the God particle, which was searched for over many years at CERN, one of the largest high-energy physics laboratories engaged in nuclear research. As for dark energy, this hypothetical substance was specifically introduced into the mathematical formula to explain the accelerated expansion of the universe. So what in this theory is real and genuine? If we put it this way, it turns out that the explosion wasn't an explosion in the usual sense. Accordingly, this phenomenon didn't have an epicenter, especially not one concentrated at a specific point. Actually, the very beginning of the Big Bang theory is its weakest point. Among other things, the inflaton and dark energy are literally two unknown quantities, artificially introduced in attempts to create a coherent theory. However, scientists do not pay attention to this, considering such points insignificant, since everything else in principle fits into the developed model. And then James Webb appeared and destroyed it completely. It's only a matter of time. You may not have thought about it, but in fact, not so long ago, humanity didn't know whether there were planets beyond the solar system. Now, thanks to modern technology, the situation has changed significantly. We know about 5,300 exoplanets outside our planetary system, a vast field for research. At the beginning of studying objects beyond the solar system, we first discovered large planets, gas giants, and then, over time, and with the development of technology, we began to see exoplanets that, in many ways, are similar to our own planet. Around 50 have been found so far. In fact, we currently know of only a few planets located in the habitable zone, which in theory allows life to emerge. However, the situation is changing. Space is gradually unveiling its mysteries to us. That is why we are discovering more and more worlds where living organisms could potentially emerge. What are these worlds? In the Milky Way galaxy, there are small systems with stars at their centers that are in many ways similar to the Sun. Despite this, it's unlikely to find a habitable planet in these systems, because most of the objects there have extremely high temperatures. However, if the main star of the system is cooler, then the habitable zone is located closer to the star itself, and at a distance of 23 light-years from our planet. In the constellation Scorpius, there is a triple star system called Gliese 667. What is remarkable about it is that in the habitable zone of one of the low-mass stars, there are several rocky planets where life could potentially arise. This is the first discovered system with such a feature. There are 3 stars in Gliese 667. The largest one is called GJ 667a, and it belongs to the K-type main sequence stars. The luminosity of this star is 88% lower than that of the Sun. At the same time, the mass of GJ 667a is 73% that of the Sun. The second star in the system is the orange-red dwarf GJ 667b, which is also a K-type star. And the star's luminosity level is 95% lower.
Процентов ниже уровня светимости Солнца.
Of particular interest to us is the third star, which was named Gliese 667c. It belongs to M-type red dwarfs, with a mass that is 1/3 of the Sun's mass. The luminosity level of this star is very low and is just over 1% of the Sun's luminosity. It may seem like a dim, cold star, but it actually has a relatively large number of planets. In the early stages of studying the Gliese 667c system, it was believed that there were only 3 exoplanets there. However, over time, as more information was processed, it turned out that there are actually 6 planets. And the most interesting thing is that half or even more of them may be suitable for life. And here we're talking about 3 or 4 planets. Just think about that. Such planets can be called super-Earths or mega-Earths. These are planets whose mass is an order of magnitude less than that of gas giants like Jupiter and Saturn, but still greater than Earths. A super-Earth can form an atmospheric layer, which may create favorable conditions for the emergence of living organisms. The planets themselves formed mainly from rocky materials, sometimes with some admixture of ice. We will take a closer look at the closest one, Gliese 667c, a planet called Gliese 667cb. Its orbital period around its star is 7 days. The planet's mass is more than 50% greater than Earth's mass. The atmospheric layer of Gliese 667cb is very dense, and it's extremely hot on the surface. The temperature there is about 200 degrees Celsius. Planets where life could potentially arise are located farther from their star. Their mass is also greater than Earth's mass. After Gliese 667, CB comes the planet Gliese 667cc, and it is located at the beginning of the habitable zone. The planet completes a full orbit around its star in 28 days. The mass of Gliese 667cc is almost 4 times greater than Earth's mass, and its radius is almost twice as large as our planet's radius. The Earth Similarity Index is 0.85, and that's a very high value. Since the star Gliese 667cb has rather low luminosity, the habitable zone is close to it. That's about from 0.1 to 0.23 astronomical units. For example, Earth is located at a distance of 1 astronomical unit from its star. If the Sun were an order of magnitude dimmer, our Earth would be a solid glacier. In the case of Gliese 667cc, its distance from its star is about 0.12 astronomical units. Most likely the planet is in tidal lock, which means it will always face its star with the same side. This will have a significant impact on the exoplanet's climate, since there will be sharp temperature differences between the illuminated and dark sides. Even though the amount of light Gliese 667cc receives is less than what Earth gets. Due to the infrared range, there may be enough energy for the climate to still be more or less comfortable for living organisms. At the same time, we don't know if the exoplanet has an atmosphere, and if it does, we'll need to find out its thickness and density. Based on this data, we could determine the approximate temperature on the surface. Let's assume that the supposed atmosphere of Gliese 667cc has the characteristics of Earth's atmosphere. Then this would more or less help smooth out the temperature fluctuations caused by being in tidal lock. Well, that's pretty good. In the Gliese 667c star system, you would be able to see both Gliese 667a and Gliese 667b. Even though they are about 230 astronomical units away, however, there are some issues with the main star of the system. Unfortunately, powerful radiation flares can occur on the star Gliese 667c. Considering the fact that the exoplanet is quite close to its star, all these processes can negatively affect potential life. On Gliese 667, the probability itself and the very process of the origin of life on the exoplanet is also directly influenced by the mass of the exoplanet itself. And that's because the mass determines what the acceleration due to gravity will be. More massive rocky planets will have greater gravitational acceleration, which implies more massive objects on the surface of the exoplanet. The same goes for the atmosphere. The greater its mass, the higher the atmospheric pressure. And living organisms, if any ever appear on Gliese 667cc, or if they already have, will most likely not resemble those on Earth, because they will develop in completely different conditions. It will be a completely new, amazing world. Let's also talk about other potentially habitable planets, specifically about Gliese 667CE and Gliese 667CF. They are even farther from their star, and it would be logical to assume that there is no chance for life to originate there at all. They simply wouldn't receive enough energy. However, if these planets have a very dense atmosphere, it increases their chances of being habitable, because the heat would be retained there much longer. Overall, it's incredibly lucky that we were able to find a system with so many planets potentially suitable for life. In the solar system, it's only Earth, but here there are as many as 3 or even 4 planets. Let's take a closer look at what actually makes a planet suitable for the emergence of living organisms. First of all, it's an adequate amount of light, which is necessary for forming an optimal climate. We need to determine at what distance the planet should be so that the amount of light it receives is just right, not too much and not too little. We define the habitable zone, which is essentially 2 boundaries. In the case of the Gliese 667c system, the inner edge of the habitable zone is located at a distance of about 0.126 astronomical units, while the outer edge is at a distance of 0.250 astronomical units, and there are exoplanets that are located exactly in this zone. There may also be liquid water, which of course is also important for the emergence of life. If a planet is located at the inner edge, there is a risk that water will evaporate quickly and a greenhouse effect will occur. If the object is at the farthest edge, its surface may be completely covered with ice. That is why, when it comes to the emergence of potentially habitable planets, balance is needed. At the beginning of the video, we said that there are 6 planets in the Gliese 667c system. However, in 2013, during research, it was suggested that there are actually 7 planets. The possible 7th planet was named GJ667CH. At the same time, it is most likely located outside the habitable zone, closer to its main star. This means that due to excessively high temperatures, there is no place for living organisms there. However, we still have 3 or 4 potentially habitable exoplanets in the system. With the development of technology, the emergence of powerful telescopes and research probes, more and more opportunities are opening up for us to study space. And we are confident that ahead of us, there are still many planetary systems with planets suitable for life. And do you agree with that? And what do you think? Is there life on any exoplanet in the GJ667c system?